Good evening, everyone. Today we are speaking at rewriting the rules, why Kubernetes is moving to NFTables. So who are we? My name is Yash Kumar Singh. I work as a senior software engineer at VMware by Broadcom. I basically work on contributing to Kubernetes, Kubernetes networks, and core DNS and CNI plugins also. And with me,
Hi, I am Daman. I am a senior software engineer at VMware by Broadcom. I am a SIG network maintainer. I am currently working on proxy.
So in today's agenda, we'll be talking a basic of introduction of regarding proxy, and then we'll be covering the limitations of IPTables and what is NFTables. And next we'll cover like how Kubernetes has adapted the NFTables. And lastly, the usage and recommendation needed for using the NFTables in the Kubernetes. So first of all, why do we need proxy? So proxy ensures that whenever you connect it to Kubernetes service, the user should be able to connect to the service endpoints. Like pods are ephemeral, it can be created, deleted, and destroyed. So in general, like in proxy basically it basically uses the modes that are like IPVS, like as you can see in the history, we use the user space, IPVS, and IPTables. So user space is kind of a legacy, and it is nowadays rarely used. So in user space mode, basically, the proxy itself handles the traffic, and it needs to handle the traffic in the user space mode. So it's like a bit of like a latency, and the throughput will be there. So the IPTables is like the default mode. Nowadays, like mostly if you deploy a Kubernetes cluster, it will have the IPTables as the default mode. What it basically does is like whenever an endpoint it's trying to connect, it basically denet it, and that you can get the endpoint created for that service. And the last is the IPVS mode. The IPVS mode basically it's like a load balancing thing. It doesn't work by itself. It just needs the the IPTables mode to work on that. So as Kubernetes is growing, it needs the modern and scalable solutions. And Kubernetes have historically used the IPTables, and which are powerful anyway, but the legacy Linux firewall system. And NFTable is the default new standard Linux management system. Basically, NFTable was there itself, but we are not using it in the Kubernetes environment. But now, like in the follow-up slides, we'll know like why we are moving to NFTables. The next is we'll cover the limitations of IPTables. First one is the linear data rule processing. So as we know, whenever we try to create a rule in the using the proxy as a IPTable mode, so in that, what it basically does is like it creates a one rule one by one, and then it doesn't jump onto the next, directly to the end of the line. It just go to a linear linked list kind of thing. So it doesn't follow any specialized data types because we cannot indices it. Every time we need to go through the rules, it just go through one by one each point, and then basically go check, okay, this rule is there, then only it will stop there, and then we'll get the result of that. Packet matching complexity, it's like for whenever a new pod is deployed, whenever a new service is created, so every service is tied to one of the endpoints. So it's like it is directly proportional, like the services endpoints, it's like the number of rules will be more as the number of endpoints and the services increases. So in the control plane, there is no incremental API. It's like whenever you are trying to write a rule, it just follows the process. It's like whenever it creates a log first, then it basically downloads whatever the IP tables present. Then after that, it edits whatever the rules created or deleted, and then re-upload it, and then release the log. So it's like every time a new rule came up, or every time new pods spawn, or in the endpoints created, it follows the same process every time. So rule installation timeouts, it's like, as you know, Kubernetes is a very large cluster as it is growing, and there are so many issues has been reported with the rule installation. Is like where customer has faced to download the rules and update it, and it faced the downtime or like in about 6 minutes installing the rules, and even timeouts also. As you can see, there is an issue created in the upstreams also. Shared tables and conflicts with the other networking components. So as we know, like kubeproxy itself needs like the networking like CNI plugins, like we have Entria, Calico, and kubeproxy itself create a rule for that. So every time, like it always try to get, like there are some tables in the IP tables, like the net table is there, and the IP table is there. So in that, like every like Entria, Calico try to make sure like their rule will be deployed on the top priority, so that it basically creates a conflict and which networking policy we are using to basically to top prioritize. Locks and multiple services can't access over the same time. As we can know, like it first creates a lock and then it updates the rule and then it releases a lock. So all the service proxies or the other networking plugins need to wait to update their rule for that. And lastly, the high CPU and memory usage. As the number of rule grows, the number of pods created, it just need to append each and every rule, delete them, and again re-uploading them, increases the high CPU and the memory usage for that. This is the one of the example I taken the snapshot of like the kind cluster. In that I deploy the kind cluster locally. In that I run the IPTables net like -t with the table, and then net is the table name, and I'm basically listening. In that, like you can see, one of the example of Docker output is like there are 2 packets with like it has 169 bytes of thing, and the protocol and options are 0, like it is nothing has been in place, and the incoming and outgoing traffic is star, like any incoming and outgoing traffic will be taken care with the source and destination pointed to 192, 168. It's just like I'm using the Docker in locally and just a rule created for that. Same like Kubernetes services, like it just, you can see for Kubernetes services, we have a rule with what is the packet transferring it is going on. Next, I'll hand it over to Daman, we'll talk about NFTables.
Yeah, so because of the limitations, we plan to move towards NFTables. This is a new technology and new standard only. So we are using NFTables for the same thing, routing, load balancing, service traffic to the endpoints. And NFTables like handle all the rules, NAT, filtering, IPv4, IPv6, all the tables are there. So one good thing about NFTables is like if you see like how data plane is programmed for IPTables, it is like a linked list only. We have set of rules and packet goes through all the rules. And for NFTable, it's like a hash map only. Powerful indexes are over there, and we can get like constant time lookups for all the service routing. NFTables also supports incremental API. So just like Yash shared, like we need some time to restore all the IPTable rules. It can take up to 6 minutes. For NFTable, it takes like, if I'm taking example of 6 minutes for IPTables, NFTables it takes around 10 seconds only. Oh. Am I audible now? Yep. So, like I said, like data program for IPTables is like a linked list only. There are multiple rules, and a packet goes through all the rules, is evaluated against all the rules. And for NFTables, we program like a hash map only. And then NFTables also support incremental APIs. Data plane programming takes very less time compared to IPTables. Then as like NFTables support multiple tables, there's a concept of tables, and all the networking components can have their own isolated tables to program the rules. The alpha support was added in 1.29, and in 1.33 it went GA. This is an example like, how actually the packet flow happens in the data programming. In the left side is IPTables, and as you can see, a packet when entering a kernel goes over all the services. Attributes based on the headers are matched, and whichever like service it is matched on, it goes to the endpoint chain, and again it traverses through all the rules in the endpoint chain. So this makes up the packet matching complexity OM into N, where M is the number of services and N is the number of endpoints. For NFTables, we have a map, and based on the packet headers, we directly do a constant lookup to which service it should point to. And after that, like we have a second round of hash table in which we randomly select a endpoint for mapping, like which endpoint should serve the traffic. Here are the rules also, like in IPTables, as you can see, there are like multiple rules. And then there are multiple endpoints based on the probability a endpoint is matched for the packet to DNAT. In NFTables, like we have maps, so we can directly create a map of all the entries. And directly using verdict map, we can match the packet headers with the map where we want to route the traffic. Again, like for endpoint selection also, we have a random map. Based on the index only, we randomly pick a endpoint to route traffic to. And since it also supports incremental API, like as we discussed earlier, so programming data plane doesn't take that much time. Here's an example of the difference between performance. As you can see, like for 30K services and P90 latency, we take example. IPTables, the time taken to for the packet is like linearly increasing with amount of the services and endpoints. And for NFTable, it is a constant thing only. So that is like one of the major difference, and that is what is powering kubeproxy. For some recommendations, like we recommend like using kernel greater than 5.13, and since support was added in 1.29, so Kubernetes greater than 1.29 or 1.31 plus will make sense to use NFTables. There are some behavioral changes as well. The first one is like node port services will no longer be available on localhost. The reason why we did that was to do that we had a hack where we enable route localnet, but that has some security complications, so we need to avoid that. And there are some cases in which there was a bug in kernel which drops the packet which were marked invalid by contract. So for that, like the bug was fixed in kernel 6.1. So if you are using kernel greater than 6.1, you should be fine with that. And additionally, if you are like configuring firewalls with a default deny policy, you might need to explicitly enable port siders to allow to make node port services work. To enable NFTables mode, you can directly configure the kubeproxy configuration. It's in a kubeproxy config map in kubesystem namespace with mode NFTables. Or you can provide the flag also, proxy mode NFTables. That should be good enough. For references, there are some good talks also in blog post. So you can also go through them. And that's it. Any questions?
Hello. That was fascinating talk. Thank you for sharing that, the problems with IPTable and FT, right? So still you are using kubeproxy with NFTable mode.
Right.
So did you try to eliminate completely kubeproxy?
So we need one solution to implement service load balancing, and that is kubeproxy entry for Kubernetes.
Yeah, but coming to 1.31 or 3.2 onwards, right? If you use, instead of, I believe you are using Calico for your CNI.
Yes, let's say.
Yeah, if you use Cilium, like did you try, Cilium can replace your service thing, right?
Right.
Where you don't need kubeproxy at all.
So yeah, CNI providers also provide a service implementation, and we can use that. And kubeproxy is Kubernetes default service implementation. Alternatives are also there.
But have you tried that?
So we have tried like a lot of Cilium provides a eBPF based proxy. We have tried that, but one of the problem was it has a lot of hooks, and it requires like certain set of expertise to manage like how you want to program the data plane. And compared to eBPF, we are also like planning to add a flow tables thing in kubeproxy, which will provide a fast path for all the packets, which will give similar performance like eBPF only.
Okay, thank you. And just another question, right? When you talk about the current NFTable environment, right? What is the cluster size we are talking?
So for the current example only,
Yeah.
so cluster were around 100 nodes only, and we programmed 30K services and did benchmarking on that.
Thank you.
Will this be default in 1.33, or I mean, when this will be a default mode?
So default mode right now is IPTables only. It went GA in 1.33.
Okay, 1.33 onwards, it will be default.
It's not the default, it's GA. It's generally available, but still IPTables will be default to allow users to migrate easily.
Okay. So as a customer, what I should be worried when I
So,
switch it to the IPv tables to NFTables? What exactly we need to test it?
so one of the major like behavioral changes the node port services. Like if you are using node port services on localhost accessing via the 127.0.0.1 address, that won't be available in NFTables. That's the major behavioral change. Otherwise, like if you're using firewall and you have a default deny policy, then you might need to explicitly allow port traffic.
Once we enable, can we disable the IPv tables totally, IP tables totally in the Linux?
Yeah, you can. So IPTables also have two modes. One is the legacy mode, one is the NFT mode. So by default in the modern distributions, the legacy mode is not enabled by default. You have to do an explicit mod prop to enable that. And the NFT mode itself programs the NFTables only, but using IPTable syntax only.
Hello. You
Oh, sorry.
so you talked about a limitation of IP tables and control planes. So there's one point conflicts with. So there's a point or there's a limitation conflicts with other networking components. Can you give any example of that?
So IP tables have only certain set of tables like filter on RT only, and every networking component tries to install rules in that table only. So there are cases where like some networking component can accidentally flush the whole IP tables. So that will actually flush all proxy rules or other networking component rules. So having a separate table gives the isolation that if any networking component is flushing a table, it won't impact anyone else. And secondly, then there's concept of priorities also. If CNI is installing some rules, it needs to go with a lower priority than proxy. So those kind of things like won't be there with the isolation of tables.
Okay. And what are those networking components?
Like Antria will install some CNI rules, Cilium, Calico, all CNIs.
Okay. So basically, these are eBPF based solutions. So are
Oh,
you pointing to the eBPF as a component, a networking component?
so EBA won't program NFTables, so there won't be any problem or compatibility issues with EBPF.
Okay.
Like Antria proxy use IPTables only, so having a separate table. Calico also has an option.
Calico has the option to use eBPF also.
Okay. And
So it's depend like what CNI plugins you are using and what is the priority set by them. We are basically talking in respect to proxy only. If you are installing any third party or the CNI plugins application, based on that the priority got changes. Same goes with the writing the rules for that.
okay. Thanks.
Hello. Yeah, can you show me the graph again, the comparison graph?
Yes.
So this is 0.6 millisecond second or what?
This is millisecond only, yes. So this is the latency for the first packet match. So once the like first packet connection is established, contract takes over. So yeah.
So I'm just saying that for 30K services, you are getting only 400 nanosecond benefit. That is correct.
Yes.
So, I mean, this is very low, right? So we can live with that IP tables. That's my question.
Oh, so as the cluster scales, it will linearly increase, right? So it depends on the cluster size as well. As you can see, like for 10K it is less, for 5K it is like negligible, only similar to NFTables only. But as the cluster size increases, number of endpoints increases, you will ultimately end up with timeouts while restoring IP table rules.
Okay, thanks.
Just one question, like, can we use SNI filtering in NFTables like we did in IPTables?
So does it like program with IP table rules?
Yes.
Yeah, definitely you can use that. You just need to be sure about like the behavioral changes and like kubeproxy run its own table and it should not install any rules in kubeproxy's table. So then you should be good.
Okay, thank you.
Hi, thanks for the talk. I would like to know in detail, like, why does node port services will not be accessible? Because fundamentally, the data structure is only changing. Implementation shouldn't, right?
So basically like localhost packet, if you think about a system, a node, and there's a packet which is routing towards localhost, it is not subjected to net filter tables. So packet doesn't go through the evaluation of all the rules which we show over here. So that means like it cannot be denatted by the rules which we have programmed. To enable like a packet to go through the NFTable rules, we have to set a sysctl setting, a route local host. But this setting will actually route all the localhost packets, all the packets which are destined towards localhost to the NFTable rules or IPTable rules only, and that can have security implications also.
How does IP table does it right
So
now?
IPTable does enable this system
By
setting, and which should not be set in ideal world.
Okay. So the security is added
Security
in
is
the
a major
tables by
reason.
default. So
Yeah.
user should know that they have to enable this
Yes.
if they have to use node.
So IPTables, you have to explicitly enable that using a configuration parameter only. So like if you in kubeproxy config map, if you enable route localnet, so kubeproxy will itself install this sysctl. But in NFTables, we are not providing that option because of the security reasons only.
Okay. But if we need it, you will still have to enable the flag.
Even if you enable this thing, you won't be able to access localhost on in NFTables mode.
Then what would be the case then? Like how to access it from the node port?
So you can use like node IPs to access node port services.
Only the local host part is not there. So
Only
IP
localhost part is not there. Yeah, yeah, only localhost. Like you can still use node IPs, internal IP or external IP. That will work. Okay.
Okay. Thanks.
Thank you, everyone.